Okay, let's look at some examples from the homework. And I want to start with number 2. So number 2 is a good applied problem. You got a note card company who has their marginal cost per card producing X note cards is given by this function. C prime of X is equal to negative 0.04X plus 85. And what is it asking us to find? It's asking us to find the total cost of producing 670 cards. So this problem, you might think, what does this have to do with area under the curve? That's what 4.2 is about. But remember, if we're working with a rate function, which in this case it is because it's a marginal cost function, that counts as a rate function. Another way I can tell is I've got that derivative symbol. And a derivative is an instantaneous rate of change. So this is a rate function, and we know that the area under a rate function represents the total amount of change over that interval. And that's what we're looking for. We're looking for total cost for that specific interval of, what would my interval be? I know if I'm producing 670 cards, I'm stopping at 670. Where am I starting at? Oh, I'm starting at 0. There's my interval, 0 to 670. So what I'm effectively doing is I'm trying to find the area under the curve from 0 to 670 of this function right here, of my rate function. Well, how do I do that? Do I need to estimate this one? No, I don't need to estimate this one. This is a linear function. I can find the exact area because this is a straight line. So if I graph this, it can give me a good idea of what this actually looks like. It might be helpful to know where it starts. To get that, all I have to do is plug in 0 to the function and I get 85. I know it's a decreasing function because my slope's negative. So the only other thing I need to know is what does it end up at once it hits 670? Once again, you can just plug that into your function and you should get 58.2. So that represents how high this function is by the time it reaches 670. Well, notice that creates two different shapes. It creates a rectangle and it creates a triangle. And I can find the area of both of those shapes. The rectangle's easier, right? The rectangle is just 58.2 times, what's this distance? It's just 670 minus 0, so it's just 670. So the area of the rectangle is just 58.2 times 670, which is equal to 38,994. What about the area of the triangle? This is a little trickier. Remember, area of a triangle is 1/2 base times height. So I just need to know what my base is and what my height is. Well, my base is still that same 670 distance. So I'm going to have 1/2 times 670 times my height. What's my height? Well, in this case, my height is this distance. And how do I find that distance? Well, that's just the difference between my starting value and my ending value. 85 minus 58.2, which is 26.8. So this distance right here is 26.8, and that's what I'm going to multiply in my formula over here. And so this area gets me 8,978. So those are my two separate areas. To get my total area, I just add those together. 38,994 plus 8,978. And I get 47,972. That's my total area. It's my exact area because I was working with a linear function. And if I go back to my context, that represents the total cost of producing 670 cards. We do have to be careful though, because all of this is in terms of cents. So this actually isn't in terms of dollars. It's in terms of cents. So to put it in terms of dollars, all I have to do is just move the decimal place over twice, and then that gives me $479.72. And that would be my answer in terms of dollars. The next problem I want to go through is number 5. And this one gives us the chance to try using a Riemann sum to approximate an area under a curve. And so here's my function, 0.05x to the fourth minus 2.25x squared plus 84. And I'll kind of show you a rough graph of what this looks like. But what I want to do with this problem is I want to show you that you don't actually need a graph in order to be able to calculate these Riemann sums. I know for some people, though, that's how you can make a little more sense of it. So this is asking me for the area under the curve from 3 to 7, over the interval 3 to 7. I can see that right there. But I can only estimate it because I don't have any good geometric formulas for this. So I'm going to estimate it using 4 subintervals, using the left endpoint for each subinterval. So what type of Riemann sum is this? This is a left-hand Riemann sum. So this is effectively what I'm doing. This is visually what I'm doing. Is I'm going to calculate the areas of those 4 rectangles in order to approximate this area. But how do I do that? Well, first off, it might be good to know, hey, what's the width of each of these rectangles? And to do that, I can just use my delta x formula. My delta x formula is b minus a over n. Well, in our case, what's b and a? B and a represent the interval, where b is the end of the interval and a is the start of the interval. So 7 minus 3 divided by what's n? N is the number of rectangles, or the number of subintervals. So in our case, that's 4. Well, 7 minus 3 is 4 divided by 4, and I just get 1. So the width of this rectangle, of each of these rectangles, is just 1. Makes sense. The interval 3 to 7 has a distance of 4, and I'm dividing that into 4 pieces. So each distance is 1. Well, that makes life a little bit easier. Each width is going to be 1. Now I just need to know the heights. Well, for this first rectangle, it's pretty straightforward. What's this height right here? Since I'm using my left endpoint, I'm going to just find the y value at 3, at my starting x value. So I'm going to calculate what f of 3 is. Remember, I don't have to rely on a graph for this. I have the equation right in front of me. And when I calculate that, I get 67.98. So that's the height of that rectangle. And therefore, to calculate the total area, I'm just going to do, so the area of triangle or rectangle number 1 is I just get the height times the width, which is just 67.98. Okay, let's move on to the second rectangle. That one wasn't too bad. Let's move on to the second rectangle. So for the second rectangle, of course, I'm using this x value to figure out what y value I want to use to figure out the height of the rectangle. Well, what x value is that? That's not the starting x value, that's not 3, and that's not my ending x value of 7. What x value is that? Well, remember, the width of each rectangle is 1. So if I just move 1 to the right, I end up at the x value of 4, and that's the x value that I'm going to be using. So to figure out this y value, I just plug in 4 to my function. I'm going to calculate what's f of 4. When I plug in 4, I get 60.8. And therefore, the area of my second rectangle is just 60.8 times, what's the width of my second rectangle? All of the widths are the same. So the width is still 1, and I get 60.8 as the area of my second rectangle. So I'm just going to keep repeating this process for my next 2 rectangles. To get my third rectangle, I'm going to go one more space to the right and get my new x value of 5 and plug that into my function. When I plug in 5, I get 59. So my area of my third rectangle is 59 times 1, which is 59. Fourth rectangle, once again, I'll move one more spot over to the right to get my next x value. Well, that's just 6. I'm going to check the y value at 6. I'm going to find that y value at 6, which is just up here. You get 67.8. Okay, so 67.8. There's your height multiplied by your width, which is still just 1. And you get 67.8 as the area of that fourth rectangle. Now notice, I didn't actually figure out what the function value is at 7, at the endpoint. That's because I don't need to. If I'm using left endpoints, I don't need to know what the function value is at 7, because that ends up being a right endpoint. And that's true for all left-hand sums, is you never actually end up using the ending point. The converse is true. If you're using right endpoints, you never actually use the starting point. Regardless, I have now calculated the area of these 4 rectangles, so to finish, all I have to do is just add these together. And I get 255.58. And there's my estimated area under this function over this interval 3 to 7. Okay, if you have any other questions on this homework, please reach out, email me, shoot me a message on Canvas and I'd be happy to help you. Good luck with the rest of the homework, and I'll see you in the next video.